All right, so here we go, our grand finale to understanding the law of sines. So as a recap, everything that we've done so far, in our notes, we've seen how not all triangles are right triangles. We can have non-right triangles, and we give that a name. We call these oblique triangles. And these oblique triangles can either have all angles that are acute, or you might have two acute angles, and then you have an obtuse angle in there as well. Now, so far we have seen the two cases where you might have an ASA property or SAA property. If you take a look at the acronyms there, then you can see that that's when you're dealing with one side and also two angles that are known. And we have also seen, just very briefly, the idea that we might also get a possibility where two sides are known and one angle opposite, and let's just say, and the angle opposite. And the angle opposite, one of them, is known. Okay, so we have those two properties that we have seen so far. We haven't quite touched upon the SAS and SS properties, but we'll take a look at those later. Okay. All right, so again, continuing with our recap, I'm just taking a look at our notes here. I'm just going to go 2 pages down and now examine the property we had just taken a look at, the SSA triangles. Okay, so these types of triangles, as you had seen in the demonstration before, this is when you don't get unique triangles. So therefore, we call this the ambiguous case. It's ambiguous because it's unknown. We don't quite know what kind of triangle we have. And so we have these different scenarios. We can either have 0 triangles, 1 triangle, or 2 triangles. And so this is what we need to figure out. How many triangles do we even have? Okay. So when it comes to finding out how many triangles you have, I want to make sure, I want to be very clear with this. When you are solving these triangles, and you see, first thing you should do is visualize. Draw the triangle, okay? And so as we draw the triangle, look at the parts given to you. Pay special attention to the letters given to you, because remember, whatever letter you have, whatever is opposite it is, make sure it's the same letter. Okay, and also one rule of thumb I like to give you is that if you ever are given an angle measure, always put that angle measure on the very left-hand side, the left-hand corner, because it just helps you to be consistent in your drawings and you can label everything in the right spot. Okay, so I'm going to go ahead and say that angle B is right here, which is 35 degrees, which means that my side opposite it right here is actually going to be a B value of 5. And then therefore, whatever is left over, I'm just going to go ahead and put here. That's an A value of 3. Okay, and so what you'll see here, I'm going to do this in red here, is I have an angle, side, side. And so that's a big clue to me. Angle, side, side. Oh, this is an ambiguous case. I need to figure out how many triangles do I have? How many triangles do I have? Okay, so to figure that out, what we want to do is, remember, treat B like a pendulum. And if B is a pendulum, you want to see where exactly does it swing to? Does it swing just too short? Does it swing just enough so it touches that one spot? Or does it swing too far where you might actually create 2 triangles or possibly just 1 triangle, right? You want to find out just how long is B that it can make a certain number of triangles. So the way we do that, the big idea here is to always think about it in terms of what is the height. So I've given you step 1, draw the triangle. Step 2, I now want you to find the height of the triangle. And the way we do that is, if you take a look at the triangle, you can see that the height can be created using a trig ratio. If we say sine of B, it's equal to the height over the hypotenuse, which in this case is A, right? It's the A value of 3. And so if I plug in my numbers, what I see is that sine of 35 degrees is equal to the height over 3. So let me do that again. I'll show you in a different color so you can see it. I'm looking at this angle 35 here, and I'm saying I need to find the height. So I'm doing opposite over hypotenuse, just like that, right? And so I'm seeing that sine of 35 is equal to h over 3. That is going to show me that the height is equal to 3 sine 35 degrees. Let's find out what that value is. Okay, so what I'm going to do is I'm going to calculate 3 sine of 35 degrees. In my calculator, remember you want to be in degree mode, that means that I have a value, an h value of 1.72. Okay, so I'm just going to go ahead and bubble that in and just kind of show you what does that mean exactly. Well, if I have an h value of 1.72, right here, here's my height of 1.72, then I definitely know, oh, look at that value of 5, right? 5 is definitely a number that is larger than 1.72. So that 5 is going to extend down, and it's going to go past 1.72. Not only that, but notice how the 5 is also bigger than the 3. So that 5 is going to be extra long and go past the height and also go past the a value of 3. So as it turns out, you're only going to be able to create one triangle way out here. That line, that purple line, will have to extend out here and create only one triangle. So in this case, now I know that I only have one triangle. Okay? So I have one triangle here. All right, so in order to solve for this missing triangle, then now I know basically that I have a triangle with 35 degrees, with a side length here of 5, and I also have here a side length of 3 right here. Okay, and then from here, I can just find the missing parts. Okay, so this is angle B, right? This is angle A, and here's angle C. So what I'm looking for, maybe I should do this in a different color actually. What am I looking for? I'm looking for angle A now. I'm looking for angle C, and I need to find side C as well. Those are the 3 missing parts. Okay, and so now that I know that I have these missing parts, I can just go ahead and solve it. And you can take a look here, and you can see that we have 35 and 5 connected together. So if we actually use our law of sines, sine of 35 degrees over 5 can equal, well, what are we missing? Well, we're trying to find angle A, but we also have side 3 there. So if I put those together, 3 is my side length, and A is going to be my measure I need to find, just like that. Okay, so to solve this, I just can go ahead and bring the 3 over to both sides, right? And I get 3 sine 35 over 5 is equal to sine A. I'm going to go ahead and open up my calculator again. Okay, whoops, I have it on the other side here. And so I'm just going to go ahead and calculate this here. So I have 3 sine 35, and all that is going to be divided by 5. Okay, that's 0.34. Now keep in mind that that value, 0.34, is right there. Remember that I don't want to just use the approximated value, I want to use the actual value. But the idea being that in order to solve for this value of A, don't forget that I need to arc sine both sides as well to get rid of that sign there. And so now with my value, I'm going to go ahead and push enter. I'm going to arc sine now. So let's see here, arc sine of, and then I'm going to go to answer, arc sine of answer, and that's going to give me a measure of angle A equal to 20.13 degrees right there. Okay, remember that this is an approximated value though. My true value is in my calculator, which I'm actually going to leave off to the side right now. Okay, all right, so now now that I know that this is 20.13 degrees, we can also find angle C, right? And that's pretty easy to find. We know that a triangle is made up of 180 degrees, so I know that technically, measure of angle A plus measure of angle B, which is 35 degrees, plus measure of angle C is equal to 180. And oh my gosh, I'm running out of space there. I'll just put it over here, equals 180, okay? And we know that angle A was 20.13 degrees, so I'm going to go ahead and add that. I'm going to go ahead and go into my calculator, take that value, and add it to 35. Okay, and we get 55.129, right? And then the value I just need to subtract from 180. So I'm going to do 180 minus the answer there. And we get an angle measure now of 124.87 degrees. Okay, so that's going to be my measure of angle C. So measure of angle, oops, it's actually up here. So measure of angle C is equal to 124.87 degrees. Oh no, I cannot write my degree symbol. 124.87 degrees. Sorry, this is getting messy. Okay, just do it like that. Okay, that's measure of angle C. All right, and then we need one more thing. We need side C. So let's go ahead and do that. Remember, try to use what's already given, which is the B value, right? It's 35 and 5. So sine 35 over 5 is equal to, well, you need to find side C, and you're going to use that proportion right there. Sine of 124.87 over, over C, which is what we're trying to find. So we just do a little cross multiplication. C sine 35 is equal to 5 sine 124.87 and divide both sides by sine 35. That will give us our value of C. Okay, and so let's go ahead and calculate that. So I have my answer in the calculator here. I'm going to go ahead and push enter. Let's see, I'm going to enter in 5 sine of my answer, 124.87 degrees. And that is then going to be divided by sine of 35 degrees. And so I see a C value of 7.15. Okay, so there's my C value, 7.15. I have my measure of angle C, and I have my measure of angle A. We have solved this triangle. We have found the missing parts. We have 3 missing lengths that we have now found, and we were already given 3 lengths, and so we have everything. We have 6 total sides. Okay? All right, that'll do it for this example.